Hello, this is Jo from Maths Tutor Me. Today we're doing coordinates and graphs, and we're going to be looking at line graphs today. Line graphs are often used to show how a variable changes over time. So, example, we have Zara who conducts a science experiment where she slowly heats up a liquid and the temperature is recorded every 5 minutes. Her results are shown in this table here. So you can see the time here increasing by 5 minutes each time, and this was the recorded temperature. Not quite going up quite so nicely as that one was. So, A, draw a line graph to represent the information. So, we're going to draw our axes on here on the edge of our grid paper. You use a ruler, always use a ruler when drawing graphs. So, across the bottom, you want to put the variable that is going up by a constant amount, which in this case is going to be the time. So time, which has units in minutes, we can put down here. It's going up by 5-minute intervals. So we could put that across here. 0, 5, 10, 15, 20, 25, 30. We have enough spaces to go up by 5s. So 0 here, 5, 10, 15, 20, 25, 30. All right, the vertical axis then needs to be the temperature, which is in degrees Celsius. Now the highest temperature we have is 60 degrees. The smallest is 15. So having to get to 60, we definitely don't have 60 spaces there. Perhaps we could go up by 5s again. 5, 10, 15, 20, 25, 30, 35, 40, 45, 50, 55, 60. Yes, that's going to make it. So let's put that in. Sometimes it takes a bit of trial and error to find a scale that's going to work for your grid. Okay, so now that we have our axes all measured up with labels on there, we can start plotting our points. When the time is 0, the temperature is 15. So 0 up to 15 will be right here. Next point, when time is 5, the temperature is 25. So 5 up to 25. 10 is 35. 15 is 42. So we have to approximate here as best we can. So 42 would be about there. 20 is 49. Just below the 50. 25 is 55. And 30 is at 60 degrees. Okay, so this isn't a perfect straight line, okay? So what we do is we got to draw little lines between each of the crosses, joining up each section of our graph like that. So it's kind of bending as it goes up. What is actually happening is that it is the temperature is not actually increasing as fast as time goes up. So in B, we want to use our graph to estimate the temperature at 18 minutes. Okay, if we come to our graph, 18 minutes would be about there, a little bit over halfway between the 15 and the 20. What you want to do is you want to draw a line going vertically straight upwards. You usually draw a dotted line for this, up to where it touches the line graph. And then you want to draw a line going horizontally across to the vertical axis. And we want to try and read off this measurement as accurately as we can. So it's right between 45 and 50. So it's probably going to be either 47 or 48. I'm going to say it's slightly below half by looking at my graph. So I'm going to say that it's about 47 degrees Celsius. Okay, so there will be, depending on how accurately you've drawn your graph, there may be a little bit of variance to what you get here, which is why it's very important to show where you've drawn your line, so that your teacher can see how accurate you have been and how you've actually worked it out. Okay, let's move on to the next question. So this is our practice time question. This is a line graph, but this is a special type of line graph that you're going to be drawing called a distance time graph. So you can give this question a go. It's a little bit different from the first one. See how you go and then restart to see the answer. Okay, so for question 1, Jack and Jill decide to go for a bike ride. They left home at 10 a.m. and travel 15 kilometers in the first hour. They stop at a park for an hour to rest before continuing at a slower pace, traveling 5 kilometers in the next 30 minutes. Without stopping to rest, they headed back home, completing the return journey in 1.5 hours. Draw a distance time graph to represent Jack and Jill's bike ride. So our constant variable here is time. All our distances are related to time. So we need time to be across the bottom. Okay, and we're going to use the units of hours. Okay, and on the vertical axis is the distance that they're traveling. Okay, so all distance time graphs will be like this. We have time across the bottom and distance on the vertical axis. So that's going to be in kilometers. Okay, so they left home at 10 a.m. We will call that time 0. Okay, and then we have a few different increments of time going from there. So let's go up in half-hour lots. So this would be 0.5 of an hour, 1 hour, 1.5 hours, 2 hours, 2.5 hours, 3 hours, 3.5 hours, 4 hours. Okay, the distance. We know that they travelled 15 kilometres in the first hour. They stopped at a park to rest before continuing a slower pace, travelling 5 kilometres for the next 30 minutes. Okay, so altogether that was 20 kilometres that they've travelled going away from home, and then they stopped to head back home. So we need to get to about 20. Maybe we could go up by 2s here. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. I have just enough room to do that. So 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. All right, let's go through and draw all those details on this graph. So Jack and Jill decide to go for a bike ride. They left home at 10 a.m, so they're leaving home. They haven't travelled anywhere. We're right here at the starting origin point. They travel 15 kilometres in the first hour. So at 1 hour, they've travelled 15 kilometres. They've gone all the way really, really fast up here to 15. So that's what they've done in the first hour. They stop at a park for an hour to rest. I guess they went a bit fast. They worn themselves out. So when they're resting, they're not actually doing any more distance from home, are they? They're just stopped. They're flat. So we draw a flat line for the next hour. So across to the 2 here, from 1 hour to 2 hours, is perfectly flat because they've stopped. Okay, they stopped at the park for an hour to rest before continuing at a slower pace, travelling 5 kilometres in the next 30 minutes. So for the next 30 minutes, that's going to make 2.5 hours. They only travel 5 kilometers, which is going to take them to 20 kilometers. They're at 15, remember? So they're now going to be up to 20 kilometers away from home. Okay, what's next? Without stopping to rest, they headed back home, completing the return journey in 1.5 hours. So they're 20 kilometers away from home. Now they've got to get all the way back again in 1.5 hours. So we're here at 2.5 hours. So that would be 1.5 would be there to get all the way back home. And that's them returning back home. There is our distance time graph. So when you're doing one of these questions, try to do it like I've just done, breaking it down section by section, drawing each part one thing at a time. Makes it much easier. Okay, so let's see if we can use our graph here to answer some questions. What happens to the line when Jack and Jill stopped? Okay, so that's an important thing to learn about distance time graphs. When you stop, the line is flat or horizontal. So the line is horizontal anytime you are stopped on a distance time graph. Question C, during which section of the trip are Jack and Jill traveling the fastest? Fastest means you're doing the most distance in the least amount of time. It's the steepest part of the graph. So if you have a look, which one looks the steepest? I think it's this one here at the very beginning where we're doing 15 kilometers in an hour, which would be about 7.5 kilometers in half an hour. Remember, this one here was only 5 kilometers in half an hour. So the section, so I'll just say the first section. First section, which is from home to the park where they had their rest. How far did they travel all together? Well, it looks like they've done all this traveling, they've come up and they've come back again. At the end, they've got 0 distance, but they had to do 20 kilometers to get all the way out here. So they did 15 plus 5, 20, and then another 20 kilometers to get all the way back home. So they've actually traveled a total of 40 kilometers. 20 to get all the way as far away from home as possible, and 20 to get all the way back home. That's the end of our lesson today on line graphs. Keep practicing and I'll see you next time. Bye.